All right, guys, I'm now done. Can you all see my screen that side?
No.
Oh, all right. Let me then quickly share it. She didn't do it correct. Can you now see it, guys?
Yes, sir, we can see it.
Yes, sir.
All right. Thank you, guys. And today it will be our last lesson with Euclidean geometry. Next time we'll be doing a different chapter. Let me quickly go to that Euclidean part, the last part that we will be doing. Are you guys all okay with this similarity part? So that we can just skip this part and move with this part of proving similarity. Are you guys still there?
Yes, sir.
Yes, sir, still here.
Yes, sir.
Sorry?
Still here, sir.
Are you guys all sure that you understood that part? Oh, let me just do this. Yeah. Okay, then I assume that you're all okay, guys. We can just quickly go to this part of identifying the angles, where they are saying we are sometimes to prove, for example, let me do this and have my marker on there. So you are sometimes required to prove equality ratios. Maybe sometimes you have to prove CD. Okay, then let's see what do they say here. They are saying when Hi guys, are you still there with me? My network just started messing up with me this side. I just want to
Yes.
confirm.
Still here,
Oh,
sir.
okay. All right, thank you guys. I'm so sorry for this inconvenience. Let me quickly share back the screen. Where were we? So we were here. I was trying to emphasize the difference between this part where we just identify triangles for ourselves, unlike when we were required to prove the similarity between the two triangles. So now here we just have to identify if that if maybe we are given something like we want to prove that a b over maybe ac, that this thing is equal to dk over kl. So what you're going to do here, you either going to look at this part on your equation on the left hand side. You will look for the three letters that can give you a triangle. For instance, in this side, A, B, C are the letters that can give us a triangle. These letters are the ones that can give us a triangle. So you will go to your diagram and look for the triangle ABC. Okay, fine. Then you go for the other part on the right hand side of the equation. Okay, here we have D, you have got K, you have got L. So you will go to the diagram and look for the triangle D, maybe K and L, and now prove the similarity between these triangles. And then now you can formulate those equalities using similarities until you come to this conclusion. Does this part make sense to everyone, guys?
Yes, sir.
Oh, okay. Okay, thank you, guys. So there they are saying, suppose, for example, you have now to prove that AB over AC is equal to BC over CD. There are two possible ways of identifying these triangles. Okay, I think I did the left and the left triangle, right triangle method. So let's go for this method one. They are saying top triangle, bottom triangle, which is triangle ABC and triangle ACD. So in this case, if you want to prove that AB over AD is equal to BC over CD. So what you are going to do, you will look at for the triangle ABC. So what they do here, they only looked for those letters on the numerator in this case. Then that will be the first triangle. And then now secondly, what they did, they looked at those letters on the numerators. Then they will give us triangle ABC. Does this part make sense to you guys?
Yes, sir.
Sir, I don't understand.
You don't understand? Is there someone who just said he doesn't understand?
Yes.
Okay. Yeah, I'm saying to you, for example, when I say maybe to you, let's say we've got this ratio. This is what you want to prove. A, B, all over A, D. You are required to prove that this is equal to this. So usually how we did this problem, in the first question, we were required to prove the similarity between maybe triangle ABC is similar to triangle maybe DEF. So, okay. Now in this part that we are in now, you are not required to prove the similarity. But in order for you to prove this, you have to prove the similarity first. So you have to just identify those triangles yourself using the information that you are given in the equation. This is how you are going to look for those triangles that you will use to prove the similarity. So using this method here, this is what they did. They looked at those letters on the numerators on both sides of the equation, okay? We've got B in common on the left-hand side and the right-hand side. Therefore, we will take the letter A, B, and letter C. Those letters will give us triangle A, B, and C. Okay, that's the first triangle. The second triangle, we're gonna go to the denominator, okay? We have got letter D in common. Therefore, here we can create a triangle A, D, and C. So we will also look for the triangle A, D, C. Then now, we're going to prove the similarity between this triangle ABC and this triangle ADC. Then after you proved this similarity here now, you can do what you know that we did for these questions to prove now that this part here, sorry, that's now this part AB over AD is equal to BC over CD. Does it now make sense to everyone, guys?
Yes.
Are you
Yes,
sure?
sir.
Yes,
Yes,
sir.
sir.
Oh, all right, all right. Let me then, guys, emphasize this before we can proceed to other part. You don't only look for the numerator part and also the denominator part. If that method fails, there's this left triangle, right triangle method that if you've got that A B over AD is equal to BC over CD, okay? You can also look for the left-hand side part, okay, formulate your triangle. You can also go for your right-hand side and formulate your triangle. Then afterwards, you create your triangles to prove the similarity between the two triangles. Then afterwards, you go to creation of those formulas that mean ABC, AB over BC is equal to AD over AF. Maybe then you give your reason that similarity triangles. Does this one make sense also?
Yes,
Yes, sir.
sir.
All right, thank you guys. If that makes sense to you, then we can just proceed to the other part. Now, let's say, oh, I believe, guys, you now can do this kind of problems, these ones here. Can you guys do something like this? I just want to confirm if you Hi guys, I'm back again and I'm sorry again. My network just kicked me out. It just kicked me out this side. Let me again go back to today's work. Oh, what's happening? Stop sharing. What was I sharing? All right. Can everyone see my screen aside? Where are my friends now? Are you guys still with me?
Yes.
Oh, all right, guys. So, guys, like I was asking you, are you all guys comfortable with this kind of questions? Whereby you are required to prove equal to that AR type question before I can jump into the next part. Where are my friends now with that feedback? Are you guys still there?
Yes.
Are you okay?
Yeah.
Yes, sir.
Oh, all right, guys. Then let's go to the next part. Okay, we just did this. So, oh yeah, let's say I've got this exercise 6 here, number A. Like you guys are saying are comfortable. We've got this exercise 6, number A, whereby they are saying in the sketch alongside AB, always AB, this part here, AB, is equal to AC. Okay, these sides are equal. They shouldn't be that long, those lines. This is equal to that. And PQ is equal to PR. PQ is equal to PR. Oh, let me use different color, maybe red. This one is equal to that one. Okay, this implies that triangle ABC is an isosceles triangle. This angle is equal to that angle there. And this other angle here is equal to that angle there. Okay, now we are required to prove that BD, what is BD? Okay, there over AC, there, okay, is equal to DR over AQ. So is there anyone of you guys who can give this question a try? Or anyone who can share some idea of how we can approach this problem?
Sir,
Yes?
can I try?
Oh, yes, you're more than welcome to
So
give
first,
this question a try.
I'm gonna think of first trying to say that triangle DPR and triangle ABC are similar by saying
B,
that
B, 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 D,
A
B, BDR, right?
yes and triangle
So
ABC intersecting triangle are
you
similar.
chose your triangle like this, right?
Yes, sir.
Oh, all right. That's 100% okay. So the triangles that you are going to look at is this triangle, BDR, BDR, and the triangle. You said this triangle
ABC.
ABC.
Yes, sir.
Why ABC?
So because that way I can link because if I can prove first that what's this triangle BTR is similar to triangle ABC, then again prove that triangle what's this okay, I don't fully remember why I did it was just a thought.
Oh, okay. First, this
Oh,
triangle.
sir. Oh, I remember why, sir. I remember why. I
Okay.
needed a way to prove that the side BR is equal to the side BD by saying that triangle ABC is similar to ADR, so that the equal sides of QPR will be the same as will be I can oh sorry sir, let me restart my answer. I was thinking that I can prove that DR is equal to BG by proving that it's similar
BR
to
and
triangle
BC.
ABC. Yeah, I wanted to prove them to be equal first,
Oh,
so
okay.
that when
Didn't you
I
think of it this way of maybe just take, pardon?
yeah, so if I can prove that
What are you
BG is
saying?
equal to DR, I wanted to do that before I prove that triangle BTR is similar to QPR.
Oh, okay.
Yes,
How then how were you thinking to do that?
I was gonna use the sides DR and the common line, which is BR. So I was gonna use
Okay.
the side BR, which is common for both, and the side BR,
BR.
which is common for both. Yeah, BR and
Okay.
DR are both
And
common
and
sides.
and DR.
Yes, and the angle R there is a common side. It's a common angle.
Angle R. What is angle R? Are you talking about
Yes,
R1 or R2?
R1, sir.
Oh, okay. So you are saying that angle.
Yes, those two sides and
Is
the
this what
angle.
you are saying?
Yes, I was gonna prove that
Okay.
after.
Then what were going to be your reasons when you were going along with those statements?
Uh, DR is common, BR is common, and um, angle R1 is common, whi- which would mean I'm using a side angle side.
Okay, let me just quickly write these triangles of yours here. You said you want to prove which triangle and which triangles that are similar, okay?
So my main ones that I want to prove is BDR is similar to
Okay, let me just,
QPR.
can I please write them down? You're saying it's triangle BDR and triangle which
Yes.
one? And which one again?
Uh, PQR.
Oh, you are saying PQR. Okay. Let me then now quickly highlight them here on the diagram. We've got BDR. BDR is this one, and you've got your triangle PQR. PQR is just this one here. Okay, that one. Then now you said this one is a common angle. Okay, I agree. And then now what do we do next?
Then we prove that triangle PQR is similar to AQC, sir.
You're saying PQ, you're saying, okay, this triangle is similar to
AQC.
AQC.
Yes, sir.
Okay. Triangle AQC. AQC. You are saying now we should go to triangle AQC. Where is Q again? Oh, this one is AQC. And triangle
Yes,
PQR.
sir. Yes, they are
Okay,
similar as
where is
well.
PQR?
It's a
PQR
very
is just
small
this
one there.
one.
Yes,
Okay, and
sir.
then your reasoning. Sorry?
No, nothing, sir, nothing.
Sorry, pardon?
I didn't say anything, sir.
So now you only have one reason to prove that similarity.
No, so they actually follow the same formula as the triangles above. It's angle means side, angle, side.
Ah, which side did you actually use? Are there some sides that are equal in these triangles? The green
They are
one
common, sir.
and that red one.
The shaded, yeah,
Pardon? Are there some equal sides?
yes, sir.
Which one and which one?
Well, once you prove them are similar, you also prove that they have the same properties, sir.
I'm lost a bit, sir. Uh, hmm. I don't know if, okay, let me just maybe try to write down what you are saying. So you said with this triangle, the red one,
Yes, sir.
and this green triangle, yes, I agree with
You prove
this
them similar.
statement
Yes,
that
sir.
R1 is equal to R1, that this is a common angle. Okay,
Yes,
that's
sir.
our first reason and the first statement. So now we are left with two statements and two reasoning.
Which is DR is a
Now this is
common
what I
line as well.
actually didn't hear well. You are saying which one is a common line?
DR, D.
DR is this
Yes,
one
the common
here,
line.
right? That one.
Yes, sir.
But yes, I agree that is a common line, but now they don't share equal length when you now look at the blue triangle and the red triangle. Can you see that? That when
Yes,
I
sir.
can maybe
Yes, because you prove it.
sorry?
Sir, isn't that okay when you're proving that they're similar, not congruent? Because
Yes,
they
we are
are
proving that.
almost, they are the,
Sorry?
no, sir, continue talking.
Pardon?
Continue talking, so you continue with your explanation.
Oh, I was saying that line DR, there is D like this, there is R there, then there is P here. So for the red triangle, we have got this side here. And then for the blue triangle, we have got this side here. So can you now see that the side, that blue side is not equal to that red side there?
Yes, sir.
Yes, therefore you cannot just go for those sides and say it's a common side. If maybe we had something like this, I was going to totally agree with you. If we had something like PR for the blue triangle, and then we also had something like this for the red triangle, I was going to agree to you and say, okay, PR is a common side in both triangles, therefore PR is equal on both sides.
Yes, sir.
It's a common side. I'm not sure if you get what I'm saying.
Yes, sir, I
Are you
understand.
sure?
Yes, sir.
Oh yeah. So
Get it.
now I think the simplest way you should have went for was to look, okay, the triangles were okay, that you wanted to prove the similarity between the triangle BDR, okay, triangle BDR and triangle ACQ. ACQ. Okay, now you go to your diagram and then okay, you look for triangle BDR. BDR is this one, and then you also go for triangle ACQ. ACQ, it's this one, and then now you prove the similarity between these two triangles here. And then now after, you can now go to formulate those equalities from similar triangles. And then now you can come to the conclusion to this. So now after you constructed this triangle, these triangles here, do you have some idea of how you can prove similarity between this red and the blue triangle? So this was a very, very powerful information that we were given here. This one and this one here. You can use this information. It's very, very helpful, guys.
Yes, sir.
Okay. You wanna give it a try? Where is she now? I thought you wanted to give it a try. So okay. Remember, guys, let me just do this. When you read our statements there, we found this information that AB here is equal to AC. We said now this implies that triangle ABC is an isosceles triangle. ABC is an isosceles triangle. Therefore, this angle will be equal to that angle. Okay, keep that in mind. And then we went to that other information here, PQ and PR. That implies that the triangle PQR and that angle will. Oh, where are you now, guys? Do you guys understand what is meant by this information here?
Yes, sir.
Oh, all right. Now let's go back to the question. Okay. We used these numerator letters to create that triangle, and then we used the denominator letters to create that one. Now we say we look at BDR. BDR is this one. Then we also looked at ACQ. ACQ is this triangle. So, okay, we go for this angle. B is equal to angle C. So, okay, you go there, angle B is equal to angle, oh, C, not B, is equal to angle C. Then your reasoning from isosceles triangle, isosceles triangle, ABC, ABC. Okay. Does this part make sense to you guys? Because we had this isosceles triangle here with this equal side, and then we said this angle is equal to that angle. So does now this part make sense to you guys? Does this statement make sense to you?
Yes. Yes, sir, it does.
All right. Then now let's just go to this triangle PQR here. Okay. This triangle here, this one. Okay, we said this side is equal to that side, and then that implied that these angles are equal. Therefore, now let me just erase this. R here, angle R is equal to angle Q. Okay, from an isosceles triangle, even this one, triangle PQR. Okay, then the last one will just be that D angle D is an angle, don't forget that head, that will be equal to that angle A there, that angle A, reason being the third angle of the triangle. Therefore, now triangle BRD is similar to triangle CQA. Then you are done proving this. Then now you can just use your letters just like we did before to create your formulas up until you prove what you are required to prove. Does it make sense to everyone, guys?
Yes, I
Are
think
you
I
sure?
understand.
Oh, okay.
Yes, sir.
Thank you, man. If you understand, I'm not sure about others if they do understand because now they are quiet. Are you guys okay with what I've just explained now? Are they even still in here? Because hey, they are quiet, these people. Oh, they are still here. Do you guys understand what we just did now?
Yes, sir.
Oh, I assume that you all guys understand. Let me just then erase this, otherwise we are done with whatever I wanted us to do tonight, guys. Now what I will do, I will just send what you guys will have to do there in the channel. Otherwise, thank you for you guys to be with me tonight. And I'm sorry for the inconvenience of the network that I've been getting some distraction. Otherwise, I'm now logging out, guys.